So I'll just repeat the yesterday's half wavelength dipole once again, whatever we have done as a brief procedure. So yesterday we have done with a basic introduction on Visual CEM, that is ESI CEM on Visual CEM software, where we have gone through 3 different domains like Mesh, CEM and Viewer. So Mesh is a designing window where you'll be actually doing some CAD optimization, CAD repairs, and even you'll observe the normal directions and you'll be doing the meshing properties. Coming to CEM, you'll be assigning your frequencies, excitations, your ports, similarly the solvers and the boundary conditions, materials, and if you want to compute some array computations, all those things will be done. So, and the viewer will be your results viewing window, wherever you can see your 2D and 3D plots. And coming to yesterday's half wavelength dipole, whatever we have done in the beginning thing. So we have radiated a dipole at 443.7 megahertz. So the calculated wavelength was somewhere like 338 mm. So we have took an approximate length of dipole, that is 337.8. So this is lambda by 2. You will be getting somewhere like 600 plus. So you'll be calculating lambda by 2. Then you'll be getting somewhere like 337.8. So initially we have to set up the units. Set up the units. So if you want to set up the units, what you can do is so initially you have to set up the units under mesh window. You'll be actually having the setup part. So just if you click on new file, under tools you have change and convert length units. So you'll be having the modeling system. Here you have to assign the units. So this is first step what we have to do. So that's what we have done yesterday also. And once it is done, then we have to go for geometry. We have to create a geometry. So for this, I have to create nodes first. So you can see node points are also mentioned. Point 1 is origin, at origin 0, 0, 0. Point 2 is at 0, 0, 168.9. This is exactly half of your half wavelength dipole. And point 3 is 0, 0, 337.8. So these are the 3 points what we have created from this particular menu. So node, you went to by XYZ locate, and then you have to enter all the points. Then you'll be getting 3 points. After that, what you have to do is you have to go ahead with connecting the points. So you'll be getting in this particular format, you'll be getting 3 different points, nodes. Now we have to connect all these points together. So in order to connect, we actually have sketch tool. So with sketch tool, we can connect all the points together. So we have to open sketch tool and click on pick points, and then we have to click on all the points like this. Click on one point after the other. Then there will be a line, thin line, which will be joining up all the node elements. Once it is done, now we have to assign mesh. So mesh is one of the important steps where you will be actually dividing your problem into subparts. So here you will be dividing your problem into subparts. Here you can specify element length as 33.78. That is nothing but almost 10 parts. That is you are creating each part of length 33.78. So together 337.8 will be divided by 10. So you'll be getting 33.78, and then some other point. So you'll be getting 10 points like this. So 0 here 33.78, and then double of that, triple of that, 4 times of that, 5 times of that, exactly half of the complete thing, and then completely 10 times of that. So this is how we have to actually implement it. So here in this step, what we are doing is we have actually splitted up the part. We have splitted up the part into subparts, and we have started evaluating. So until this part mesh is done, and then we went with Visual CEM. So under Visual CEM, first thing what we have to do is we have to set up what kind of domain technique you want to use. Either you want to go with frequency domain or time domain. So in order to do that, you'll be having view. So you'll be having view SEM tree views, E field FD, So you have to set up this particular frequency domain. So whichever domain you're actually using, first step you have to do this. So by default, whenever you're starting, maybe most probably for all the systems, it will be in E field FD only. So this step you have to do it. This step everyone has to remember. And then now we have to assign step by step. Now we have to assign a material. So material properties will be assigned here. If you go for material editor, we'll get a material window. Here we have to go for metallic wire and give the radius as specified in the design. And then we have to go to part manager, which is available beneath this option. See, part manager, you have to assign the part with the respective part. So here I don't have any parts. That's the reason it's completely empty. So once you have created a part, you will be assigning it. So here my metallic material has been assigned to a dipole, whatever I've created. And after that, I have to create an exterior boundary, exterior medium around my all parts which are present in the antenna. So there is only single part. So the single part will be exposed to exterior boundary. So in order to go with this, we have an option called as medium. You have to click on medium and then you have to apply exterior medium. You have to click on part. You have to assign the part and click on apply. So once you click on apply, exterior boundary will be, exterior medium will be applied on a surface. And once it is done, now we have to assign the frequency, intervals of frequency, that is 433.7 megahertz to 453.7 megahertz, 21 set points. So it starts from 433, ends at 453, 453.7. So this is one thing. And after that, what we have to do is we have to pick up exactly the middle point of node. So the middle node is nothing but it actually diversifies your dipole into half. So that point, either you can project it. See, you have to select the middle node like this. And then once you click on OK, automatically what happens is either your dipole will be projected in top direction or in the bottom direction. So it's like this. You have to go for sources, you have to go for delta gap. So you'll be getting this kind of menu. So you have to select the node. Always it should be real time, real voltage should be 1, imaginary should be 0. And then impedance should be 50 ohms, characteristic impedance. And here we'll be actually giving the direction. So which direction you want to radiate it, either in the positive Z direction or negative Z direction. What you can do is you can put +1 or -1. But here what happens is, even though if you're not putting it, by default, you may get it in +1 or -1 direction. So you have to check this once you are closing down, you have to check the bottom menu also. So if it is not available, then you have to give it 1. But most probably this thing will be already allocated. And then we have to create a far field around the dipole antenna, far field. Once it is done, then we have to go for excitations. Under excitations, I have to give my delta gap, whatever I've created. I have to give my far field sphere, whatever I've created. And I have to give my currents and surface powers, whatever I require. And since I'm using my delta source, the final output should consist of delta source, like input power, input impedance, reflection factor, SPWR, etc. And then we have length units in terms of mm. That's fine. So after this, we have to save the project. We have to go ahead with job manager. We have to run the design. See, here also it's the same. You will be actually getting the exe path and then working directory, and then you'll be getting a input file. This input file will be available if and only if you are going with this particular step. If you're not saving your project, you will be not getting any dat file. If you're not getting any dat file, it is unable to run. So you may not get the results. After that, we have to go to result viewer. We can visualize all the results. So this is input impedance. We can also calculate the input impedance, just like we have to go with this. So once we are done with the design running, basically we'll be getting a ERFH5 file. So this ERFH5 file will actually give all the results, have all the results inside it. And whenever you're plotting different type of results, you'll be actually getting your input power and all other things. So you can go for 3D visualization also, electrical wire currents, how exactly it is flowing out. And similarly, you can go ahead with the directivity plotting as well, how exactly your directivity is available. And similarly, you can go with low-bit plot and as well as non-low-bit plot also.
Sir.
Yes, sir.
Monica raised the hand. Monica, you have question?
Yes, sir. Actually, sir, the multi-source window, how do we get that, sir?
Yeah, multi-source. Okay. So in SEM, you have this single excitation, right? So you can click this. So if you click on excitation, this is a window where we'll be actually assigning the excitation. Multiple source is also the same window. If you're having the multiple sources, today we'll go with multiple sources example. You will have a look at it, how exactly it comes up. So this is nothing but your source window, excitation window. For some cases, the excitation window will come automatically, just like what we have observed on the horn antenna. Yesterday, we have done a horn antenna where we have went with the port excitation. When you're exciting a port automatically, you'll be getting an excitation. There you have to define all the parameters. But whereas if you're going for delta gap source, you have to create this excitation explicitly, and then you have to assign the source, delta gap source, and then you have to assign your far field sphere. And then if you want to see your currents, you can go with currents. So this is nothing but your excitation definition window, what I can say.
Yes, sir.
Okay.
Srikant, if you have urgent question, then you raise. Is it related to now?
Yes, sir. Regarding to the dipole antenna.
Yeah. Go ahead, ask.
Sir, that tree diagram also not showing like as like a PDF, sir. It's like some of the part is not visualizing in the while practicing.
But sir, parameters and just you check.